Today, we are diving into one of the absolute coolest and, honestly, most important ideas in AI right now, model distillation. The best way to think about it, it's basically a mentorship program where a giant super smart AI takes a smaller, more nimble AI under its wing and teaches it everything it knows. So let's get into how this whole mentorship thing actually works.
So here's the big problem we're trying to crack. You've got these genius-level AI models, right? Think GPT-4. They're absolutely massive. They need huge data centers to run, and they're way too slow and bulky for your phone or your laptop. So the question is, how do you get all of that incredible brain power into the devices you and I use every single day? Well, it turns out you have the genius teach an apprentice. And that's exactly what model distillation is. It's really a clever way to compress a model. We take this huge, powerful teacher model and use it to train a much, much smaller student model. But here's the key. The goal isn't just for the student to memorize the right answers. The goal is for the student to learn how the teacher thinks, to capture all of its subtle insights and knowledge, but in a much lighter, more efficient package. Okay, so if the big teacher model is putting together a lesson plan for its new student, what's actually on the curriculum? It turns out you can transfer knowledge in a few different ways, and each one gives the student a different kind of insight. Let's break down the syllabus. It pretty much boils down to three main types of knowledge. First, you've got response-based learning, which is all about the teacher's final answer. Then you can go deeper with feature-based learning, where the student tries to copy the teacher's actual thought process. And finally, there's relation-based learning, which teaches the student to see the world and the connections between things, just like its mentor does. Let's kick things off with response-based learning. This is the most common approach, and it has this really cool concept called dark knowledge. See, the teacher doesn't just tell the student, hey, the right answer is X. Nope. It gives the student its full range of possibilities, what we call soft labels. For example, you showed a picture of a husky. The teacher model might say, I'm 90% sure that's a husky, but there's a 5% chance it's a wolf, and maybe a 2% chance it's a malamute. All that extra info, that's the dark knowledge. It's so rich because it teaches the student how similar these concepts are, which is way more valuable than just getting the single right answer.
Now, to learn all that, the student needs a way to measure how close its own guesses are to the teacher's. This gets a little technical, but the two main tools for the job are forward KL and reverse KL divergence. Think of it like this. Forward KL encourages the student to consider every single possibility the teacher mentioned, even the weird long shots. This can sometimes make the student's output a little messy. Reverse KL, on the other hand, is much stricter. It tells the student just focus on what the teacher thinks is most likely. This mode-seeking approach is usually what you want for generating really high-quality, precise text. Choosing the right one here is absolutely crucial.
So the next level up is feature-based distillation. This is where things get really interesting. We're not just looking at the final answer anymore. Now the student literally gets to peek inside the teacher's brain, so to speak. It watches the teacher's internal machinery, the hidden states, the attention patterns, and tries to copy that entire process. It's like instead of just learning the answer to a math problem is 42, you get to see every single step the teacher took on the chalkboard to get there. It's way more involved, but you end up with a much smarter student. And the third type is relation-based learning. This one's a little more abstract. Instead of copying specific numbers or features, the student learns the teacher's sense of similarity. It learns to understand the relationships between different pieces of data. So if the teacher model thinks two sentences are very close in meaning, the student is trained to see that exact same relationship. It's all about preserving the teacher's nuanced structural understanding of the world. Okay, so we know what the student is learning, but how it learns really depends on the classroom itself. And more specifically, it depends on how much access the student actually has to its teacher. This brings us to a really important idea: white box versus black box distillation. In a perfect world, you've got a white box scenario. The teacher is a total open book. We have full access to everything, all its internal parameters, its probabilities, the whole shebang. This lets us do that really deep, feature-based learning we talked about. But the reality is a lot of the very best models are proprietary. They're black box teachers, like GPT-4. All we can do is send them a prompt through an API and get a final answer back. We can't see how they work on the inside. It's like trying to learn from a mysterious expert who only gives you the final answer, never the method. But, of course, researchers have come up with some brilliant workarounds. One is proxy-based distillation. The idea is you first train an intermediate model that you can see inside of, a proxy, to act as much like the black box teacher as possible. Then you just distill from your proxy. Another really cool method is generative adversarial distillation, or GAD. This brings in a third model, called a discriminator, that acts like a judge. It constantly gives the student feedback on how well it's faking it, how closely its answers match the mysterious teachers. And this field is just moving at lightning speed. There are new, even more sophisticated teaching methods popping up all the time. So let's take a look at some of the really cutting-edge stuff that's pushing this whole idea forward. One of the most exciting new techniques is called rationale-based distillation. This is huge. Instead of just learning the answer, the student learns the reasoning behind it. You prompt the teacher model to not only give an answer, but also to explain its chain of thought, its step-by-step logic. Then, the student is trained to generate both the rationale and the answer. This is how you teach smaller models how to actually reason, and it lets them punch way, way above their weight class. A couple of other really cool methods are taking off too. In multi-teacher distillation, you have the student learn from a whole committee of different expert teachers. This gives it a much broader, more well-rounded education. And then there's self-distillation, which is kind of mind-bending. A model literally becomes its own teacher. Maybe deeper layers of the network teach the shallower ones, or the model just keeps refining its own knowledge over and over. It's a pretty amazing way for a model to pull itself up by its own bootstrap. Okay, so let's zoom out. We've gone through all these technical details, probability distributions, hidden states, rationales. But let's ask the big question. Why does any of this matter? What's the real-world impact of this whole AI mentorship program?
Well, the impact is absolutely enormous. Distillation is the key that unlocks powerful AI on your phone. It slashes the insane computational costs and energy use, which makes AI way more sustainable and affordable. It lets us create these tiny, super efficient models that are experts at just one thing. And really, this is the tech that's paving the way for us all to have truly personal AI assistants right on our devices, fast, private, and always there when we need them.
When you get right down to it, model distillation is so much more than a compression trick. It's a fundamental technology for the future of AI. It's how we get this incredible power out of the data center and into the hands of everyone. And it leaves us with a pretty mind-blowing question to chew on. What happens when every single device we own has its own expert apprentice inside, ready to help at a moment's notice? The possibilities are just staggering to think about.